Alright guys, here we are with number 6. First thing, Mr. Jacobs was kind enough to point this out for us when we were doing this in class. This NOT operator here, right, is supposed to have a circle at the end. So somebody messed up there. I don't want to point fingers, but let's just be honest, it was probably CC's fault. Alright, so here I'm going to go ahead and take a look at these across the various points. You can see there's no XOR, so I feel pretty comfortable making a logical statement for this one. Okay, but here I can see at this first operator, I've got A and B both go in. So at this point, this is going to be A and B. Okay, then that's going to go through a NOT operator, right? So at this point, that's going to become tilde A and B. All right. Now it's a little silly, right? Because they put it through an AND gate and then a NOT gate. That would have been the same thing as putting it through a NAND gate, right? So they could have just done that. Not a big deal. All right. Now down here, I'm going to go ahead and see that B goes into this one along with C, and this is a NAND operator. So right off the bat, this is going to be B and C, but negated, right? So you can see it accomplishes the same thing the first two gates did in one, right? So here I end up with kind of a negation of B and C there, right? Now that's going to flow into my OR operator along with this, right? So at this point, I'm going to have tilde A and B, right? Or tilde B and C. Right, so again, kind of an interesting output that we get here along this OR operator. And then that's going to flow into our NOR operator along with this initial statement, right? So my final output X is going to take those two inputs, tilde A and B, or tilde B and C, right? It's going to put an OR operator between this statement and my other input, which was tilde A and B. Okay. And then finally it's going to take that whole expression here and it's going to negate the whole thing. So here I think you guys can see where De Morgan's law is definitely going to help us with this one, right? So I'm going to distribute my negations to get some double negations, and then I'm going to go ahead and kind of take care of that. Now we want to do this slowly, so just take your time with this, right? I'm going to extend this negation. I'm going to apply it to this whole bracket. So it's going to go outside that bracket. And then I'm also going to apply it over here to this negation. And remember to change that symbol. So the first thing I'm going to get, negation outside the bracket, tilde A and B, right? Or tilde B and C. Right, I'm going to keep my bracket. That OR right here is going to become an AND, and then I've got a double negative, so this just becomes A and B. Okay. Now I'm going to do the same thing. This time I'm going to go ahead, I'm going to distribute this tilde to both of these statements. I'm going to change that one in the middle. Now here I get some double negatives, so this works out really nice. So I get A and B, and B and C, and A and B. Alright, so this is kind of an interesting one. If we really look at what's going on here, for A and B to be on, they both have to be on, both A and B. For B and C to be on, they both have to be on B and C. And for A and B to be on, again, it's already on, so it's kind of redundant. So what this problem really looks for is when are A, B, and C all on, right? So we can actually really simplify this one if we think about this, right? So let's talk about what's actually happening here. These two B's, right? We can switch these if we want, right? We can call this one B and A, right? B and A, and B and C. And then we can almost, it's like factoring, right? Not really factoring, but we could almost factor out this B and, right? So we end up with B and then we're left with A and C. Right? Kind of a weird thing, right? And then kind of the same way here, right, where we have this and A and B. And if we want, we could factor this and B, this B end here. We can factor those out, right, and we'll be left with B and this becomes A and C and A, right? And again, these A and A's, A and A is the same thing as just saying A, right? So you can see this really simplifies just B and A and C, right? So this table, while the diagram got really complex and the statement got really complex, it really simplified easily to just be A and B and C. So here, if I go ahead and build my table, A, B, C, I'm just going to go right to the output X, right? So what's going to happen here, right? X is on when A, B, and C are all on. So we got 0, 0, 0, 0, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. I must have missed a 1 here, sorry. And then 0, 1, 0, 1, 0, 1, 0, 1. And you can already tell what's going to happen here. There's only one situation when the switch is going to be on, right? Because I can chunk these four. I know if A is off, this has to be off, right? And then I can chunk these two and say, well, if B is off, X is off. And then here I got this one where C is off, so it's off. So this ends up being my total output. Now, if you want to do that more complex with more columns and rows, you could. I assure you, you will arrive at the same conclusion I did. Again, barring me making a mistake along the way.